metal rods M and N, so we have two metal rods with the same cross-sectional area. Write down the statement. So A for rod M is equal to A for rod N, and length 25 cm for M and also 75 cm for N. And from the figure 8 here, we can also have the information of temperature. Okay, 140 and 0. Heat flow is from left to right. So this is the direction of heat flow. The thermal conductivity of the metal rods M and N are Km and also Kn. So the values are not given. Both rods are well insulated. So when it is saying from the question that it is well insulated, meaning that they are in steady state or steady condition. The rate of heat transfer for M and N is equal. So the first question is to calculate the temperature gradient for both M and N. Alright, the solution for the first question, okay, we want to find dt over S for M and N. Okay, so this is for M. It is equal to T final minus T initial over S, the length. So it is equal to 40 minus 100, and the length for rod M is equal to 25 times 10 to minus 2 meter. Okay, and the value is negative 240 degrees Celsius per meter. Okay, for the temperature gradient for rod N, we just use the same equation, but this time we use the temperature initial and final for rod N. Okay, so you can see here it's 0 minus 40 divided by 75 times 10 to minus 2. Then you'll have negative 53.33 degrees Celsius per meter. So that is the first question. The second question is, which rod is better in thermal conductor? So thermal conductor is represented from the value of K. Okay, so we want to know which rod is having a bigger value of K. Okay, bigger value of K means that it is a good conductor, better conductor, or better in conducting heat. So how can we conclude? So it's basically, first we need to know that relationship between K and temperature gradient. Okay, so from the equation, okay, K is basically inversely proportional with temperature gradient. From the first question, we can see that dt over S temperature gradient for object M is bigger than the temperature gradient for object N. Okay, this means that our K for object M is less than K for object N. So the answer is N is a better conductor. So this is the answer. For the third question, we want to determine the ratio or the value of Km over Kn. So it's basically the ratio of Km to Kn. So this is what we want to find out. Okay, as we know from the question, I have mentioned just now that the rate of heat transfer for M is equal to the rate of heat transfer of rod N. So both are the same. So now we can expand the equation from this situation. So negative Km Am, okay, dt over S Sm equal to negative Kn An dt over Sn. Okay, so from the question we know that the area is equal, so we can cancel out area. Negative can also be cancelled out. Okay, so we want to get Km over Kn. This is basically is equal to dt over S for N divided by dt over Sm. And from the first question, we have calculated both gradient. So it is equal to negative 53.33 over negative 240. Then finally you'll get 0.222.